You might remember being told early on in your geometry careers that if you take three random segments, we'll take our red, green, and blue here, that we could arrange them to make a unique triangle. The whole side, side, side concept. But we can't forget this obvious restriction. So let's have a look at this. So yeah, I suppose we could make a triangle like this, but we have to remember we do have a limitation. What happens if the blue segment gets really short? Short, 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 short. Oh, the triangles disappear. Quite simply because the blue and the green added together are less than the red. Can't be. The blue plus the green must be more than the red, just like going the other way. Oh, see now the red and the blue are less than the green. So red plus blue length must be greater. That's true for any two sides. Any two sides must add up to more than the third side, or the triangle just disappears. And there's your demonstration. All right, exercises 13 through 15 are drawing. And if you're following on your iPhone, I doubt you can read this, so I guess I'll talk you through it. In 13, we've got triangle with these dimensions, 9 meters, it says about, and we've got a 3, 7, and 9 meters with the longest side on the bottom. And we've got these other angles. We've got 16, a 41, and a 123. And it says that the smallest angle's at the left. I like that. Because the smallest angle here is opposite the smallest side. The 41 would be here, and the largest angle must be opposite the largest side. Well, there you go. That's 13. Let's draw 14. Now we've got 12, 35, and 37 respectively. It says with the shortest side at the right and with the right angle at top. You know, I could interpret it like this, but I think they probably meant, ready, that. Either way, I'd take either of those interpretations. And we're looking at these various, let me see, we've got a 71, we've got a 90, and we've got a 19. Well, we're already told that got a right angle, so we know that goes there. And let me see, we got a we angle, must be opposite the we side. And this angle, that's pretty close, the middle angle, opposite the middle side. Oh, we're really getting the hang of this. All right, one more. Let's even make this one bigger just for fun. So we've got 11, 13, and 14 along the side and the bottom. That would be the 14. And we've got two angle measures given. We've got 48 and 71. Say with the largest angle on top. Who are they kidding? We know the largest angle's on top because it's opposite the largest side. But we only have two angles. Fear not, because we have the third angle theorem, which tells us that the missing angle is, of course, 61. Largest angle, opposite the largest side. And let's go for the middle, opposite the middle. And the we angle, opposite the smallest side. And that's it. Well, two quick exercises. Can these, well, three sides be triangles? Number 17, 3, 6, 9. Well, we made a little visualization for you. What would happen if we try to connect them? They get so close, so close. But when we connect them, it doesn't work. See, because the two sides, 3 plus 6 equals 9, those 3 points would be collinear, would not be a triangle. Over here, I don't think there's any question about this. I don't even have to get out the old calculator. I can see very clearly these two points can meet. Those three sides, any two of those sides add up to more than the third. So we have a no and a yes. So which of these can be a triangle? You know, just seeing that 3, 4, 5 makes me want to say A. But be careful, grasshopper. We know we have to watch the units. That's 3 yards, 4 feet, and 5 yards. I'm going to change it up a little. Now I'm going to convert to feet. easier to multiply by 3. In B, I'm going to move to feet, and in D, let's go to inches. Now, let's look at these inequalities. A, out. Well, there you go. That's not going to work. Moving down, let's look at C. Those two sides equal the third. That doesn't work. And on here at D, now 11 and 12 are less than 24. The only one that remains is B. And I check all 3 possibilities, and it all looks okay to me. Honestly, you don't really need to check all 3. I would just, if you just added up the 2 smallest and made sure they were greater than the next large, and what would that be? That would be this one. So the other ones obviously are going to satisfy the inequality. In these 3 examples, 22, 24, 26, we'll find the possible range of values. No trick questions here. All the units are, see, they all match. So let's just have a look. We'll start out slow and pick up the pace. Now I've got 3 meters and 4 meters. Well, imagine if I move this way, S gets smaller, 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 approaches this, and then, bigger, 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 bigger. It can get infinitely close to, but it can't quite be 1. You can see that. That's going to have to be the lower limit. The lower limit's 1. It can't be equal to 1. Be close to it. And that, of course, would be 4 minus 3. Now, on the other end, see, S grows this way or S grows this way. And it gets bigger, 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 until we're in danger of, again, going collinear. Of course, we go too far, S gets smaller. And at the point where they're all collinear, 4 plus 3 would be 7. So that would be the upper limit. So we found the lower limit by subtraction, the upper limit by addition. We can express this as an inequality. S is between, I like that word, between, which is greater than 1, not equal to, and less than 7, not equal to. There you go. Between 1 and 7. Okay, that's one exercise, and we can speed it up now. You got the idea. Let's look at 24 for T. And again, we've got consistent units. And what do you think? 13, 23 minus 10? 23 plus 10. So T is between 13 and 33 yards. Okay, one more, really quick. Hey, wait a minute. 25 and 25. That looks like it could be 0. Approaches 0. This end, upper limit, approaches 50. And that's it. Okay, we'll record these 2, although they don't look very tough. I just want to remind you, well, maybe the author is worried that you don't know what to do with these expressions. Remember these radical expression in simplified radical form. If you recall, well, your calculator would tell you, radical 13 is about 3.6. Radical 2, you'll see so much you know it's about 1.41. Remember, resolve the radical in decimal. Leave all the numbers in the register. Then, in the case of the radical 13, then multiply by 2. You'll have this, take the square root of 2, leave those numbers in the register, then multiply by 5. And this is about what you'll get, rounded to the nearest hundredths. Well, I did that. And then let's see, well, they all look good. See, they're all close to 7. I don't even have to check. I know these are all. Yeah, I know any 2 of those are going to add to over 14, and it's going to be greater than the third side. So that's a slam dunk, but let's put them in order right here. Here's a scale drawing, and just with their decimal approximations. And let's see, which way do we want to go? List the angles in order from least to greatest. So that whole thing about the alligator opening his mouth. Smallest side, opposite the smallest angle. Oh, I like how this works. And let me see, here's the middle side, opposite the middle angle. and the grande side. And that would be the big alligator. Roar. So there you go. In the order. And that's, well, in the order of the angles from least to greatest. Oh, and how about that other one? Well, same thing. Radical 29. Take the square root of 17 times 2. And to the nearest hundredths, you get these decimal approximations. And I can see just doing the arithmetic in my head. Let me see, 13, 4, 3, 5, 6. That clearly these two, ST and TU, are less than SU. So this is just not a triangle. 1 out of 2 ain't bad.